everyone, and welcome to our Tech Talks at Rocket. Today we would like to introduce to you the innovation project AutoMess3D. It's about automatic measuring and analyzing system for shape and positional tolerances. But first of all, I would like to hand over to Alex van Geldrop so that he can introduce to the Rocket Reloaded project and give a short introduction into AutoMess3D, sorry. So the stage is yours.
Yeah, thank you, Hendrik. Yeah, so thank you and welcome everybody. My name is Alex van Geldrop. I'm the project manager for OostNL, but more specifically, the reason I'm here is I'm project manager for Rocket Reloaded. And it's my pleasure to give you a bit of background for the AutoMess3D project that you'll be hearing about in a few minutes. I'll try to be brief. I should be brief. But just so that you know what the framework is in which the AutoMess project was developed. So the AutoMess project is actually one of the projects within Rocket Reloaded. And Rocket Reloaded as well as Rocket are two projects that were developed within the Interreg program. And to start there, the Interreg program is a European program focused on two major goals. On the one hand, to make sure that companies within, in our case, the Dutch-German border region can remain competitive. So to stimulate them to innovate, to become future-proof, and to make sure that they're working with the latest technology, so to enhance those capabilities. And the second goal of Interreg is to strengthen the ties between those companies within the border. So not just stimulate them individually, but always to make sure that Dutch-German connection is made. So each of those projects within the Rocket and Rocket Reloaded program has the minimum requirement that there is a Dutch and a German SME that are leading the consortium. And there may be a lot of other partners, but those ties between the Dutch and the German organizations, companies, are the primary link to make sure that the Dutch-German collaboration is enhanced. So in general, within the Rocket project and the Rocket Reloaded project, there were 17 innovation projects developed, from which the AutoMess3D project is one. And we didn't do that alone. So just a quick introduction about with who we did that with. As OostNL, we were the lead partner, but we did that as well with NMWP.NRW, so the Nano Micro Werkstoffen Photonica cluster in North Rhine-Westphalia, with Holland Semiconductors, or better known for most of you probably, with HTNL, and with the transferagentuur Fachhochschule Münster. And other partners that helped us with that, two are now associate partners, but were full-fledged partners within Rocket, Innospelli and Novelty, and in collaboration with the BOM from Brabant. So together we were responsible for finding the right ideas, scouting the ideas that had the possibility for the highest impact, the highest economic revenue and job growth, societal contributions, etc., and making sure that we supported those companies to develop a project plan and support them as well during the project period when they are developing it. I think that's also the call to action. If you are currently working on an idea and you want to have some support in seeing what your next steps should be, then these organizations might be able to help you. So just reach out and we might be able to help you directly or possibly with future programs such as Rocket Reloaded. Okay. As a final slide, the AutoMess3D is one of the projects and the project that we will be hearing about today. If you want some information about the other projects, visit the website. It's listed here above, rocketinnovations.eu with a dash in the middle. And it gives you a lot of information about each of the other projects, including for a lot of them, movies giving detailed explanation, explaining the technology, but also the impact that it will have, and also some figures on what we did. And I think one relevant figure from this infographic that I want to highlight is that in general, the public funding that we received from the regional beneficiaries had a return on investment of over 400%. So that means that for each euro that the Bundesländer and the provincies invested. The companies invested over €4 in innovation projects, which is a pretty nice result. And but that's the financial side of things. We're obviously more interested in to see what the products and the technology that is developed will bring. So for that, I'll give the microphone back to Hendrik, and I wish you a pleasant webinar.
Yes, thank you very much for this short introduction. And now I would like to hand over to Thomas Kropp from Ahrens Digital Services. It's the lead partner from the AutoMess3D project. So now the floor is yours.
Yeah, thank you to everyone. It's a great pleasure to talk to you now and to have a presentation of our project, the AutoMess3D system. So first of all, I like to introduce our partners. First of all, in Holland is Centrium. This is a company which is specialized in lean management. Then Van Borkum Group. There are mechanical engineers on mechanical workshops, which help us a lot to set up the prototype. Then 3D D3 Systems in Velbert, which is also a part producer specialized in plastic parts in injection molding. And at least ourselves, Ahrens Digital Services, based in Weeze, we are a service partner for 3D scanning and measurement. So Centrium Lean Management Industry 4.0 Technology and Innovation. This is the aim of Centrium. Then Van Borkum Group is industrial automation and production of some different machines, specialized machines. This is very interesting. You may have a look at their website. This is super interesting. And then 3D system, for example, you can see a field scanning system in the background. This is a product which they develop and makes the tooling and the production. And so this is a very nice partner for us to fulfill all our ideas up to a living prototype. And ourselves, as Ahrens Digital Services, what you can see is a handheld scanner at the left, where we can make services in industry on the spot. And we focused on, first of all, on reverse engineer. You can see this small picture on the right side, where a scan part is reversed into cut data, or on the left side is a measurement result, where you can see a heat map with a part where we investigate and see if all the measurements, all the dimensions are fulfilled. And so, for example, our daily work is, for example, you have a point cloud or a scan result on the left side. This is a door, and our customers like to have this door as a cut data because you want to change some items. And actually, the car is from Ford, and nowadays no one can go to these OEMs and ask them for data. You can buy a car, you can drive it, you can do whatever you want with it, but you are not able to get data. And so the possibility for us or our service we offer is that we can scan such parts, and using our programs to make reverse cut data, where you can receive it in any common computer-aided design program and make your work whatever you like. And actually you can scan parts from any size. For example, here you see a big Mercedes vehicle where we have a full body scan. It's for the tuning industry. They make a body kit from it, and so they need these data. And we go into a Mercedes shop and ask the general manager if we are able to borrow such car to scan it. And you see the result as a point cloud. And afterward, we reverse some different parts from the chassis to give it to our client. And the other specification is quality management. And traditional, you have these coordinate measurement machines, which is quite common in most of the companies. The good benefit is they are very, very precise. Some other benefits is, or not so good benefits, is that they are completely stationary. They are very huge and heavy, so you cannot transport it to a spot where the client need it. And it's quite difficult to use, so you need an expert to set up the programs, to use the machines. And this is one of our ideas which comes into our project. And in comparison to this, a much more modern way is this structure light scanner, which is a system, for example, which delivers a company Zeiss or GOM. It is absolutely high precision. It is, of course, also stationary. You need a lot of material to transport it to the customers if you want to use it on the spot. And of course, it's the same as these coordinate measurement machine. It's very difficult to use. You need a lot of training in the first just to set up the machine, and also a lot of practice, daily practice to be sure that you fulfill all the specs your client need. So the result of the scanners are much more interesting or easy to understand. For example, you see here a plastic part which is one of our benchmark in our machine. And you can see this heat map, which means the tolerances is driven up by a plus and minus scale. You can see 0.3 is red, is oversized, and minus 0.3 in blue is undersized. Every area which is more or less green or even yellow is in a very nice tolerance, and you can easily see what you are interested in. And also you can make spot marks. You can also see all these small little flags where the difference from the original CAD data to the scanned part is measured and assigned out. And so, yeah, it's a very nice way to show the customers the result. In comparison, you can imagine a coordinate measurement system is only able to measure one spot or even a lot of spots. It takes time, and even it's not so visible by these heat maps. This is just one dot on the CAD data, and even you have a lot of table works like Excel results where you can see the plus and minus, and it's very heavy to understand. And what you can see here is the way how these kind of machines is working. I make a small video. Here's a small earbud from Apple, and you can see this frame and this refraction light. This is the blue structure light, and the machine is turning this frame, the holder, 360 degree on a specific angle, and this should be programmed in before, but then you can use this frame to scan these earbuds from both sides. The frame is turnable. You can turn it 180 degrees around, so you can also scan the back side and the front side. And the scan or the software is able to match any or even any single scan to full volume. And afterward, you are able, for example, to compare it with the CAD data, which is in the measurement program and passed over to get all these results. The measurement accuracy, you can see here, this is a tool head from a lathe, for example. This is just maybe 9 millimeters big, and you can see how accurate the scanners can be. So we are talking about a minimum of microns. When you look at these structure on the surface, this is just like a kind of light irritation. This doesn't mean that the surface is really rough. This is more a kind of mathematics problem to bring up areas, rounding, cylinders, cones into these structure and get the right results out of it. Even you can filter these point cloud. It looks much better then. But this is just a visual effect. The accuracy of these kind of parts is really dramatic high, and it's getting also better and better. And so we can reach at least the specification of coordinate measurement machines, but you can have a much more, what I said, full volume, not just even spots on the surfaces. And there's also no limitation in width or in size. You can see here a big casted part, which is measured by these machines. So you have a structural light scanner, what you can see here on the tripod, and it have a scan square from maybe 0.5 meter, and you go step by step over the whole surfaces, and the software is matching the whole geometry itself together to one big volume, and then you can go for reverse engineering or even for measurement. And yeah, the aim of our project is to look deeper in these typical production processes. Our clients have mostly the problem to see, for example, in a night shift, if a part which is produced, for example, by injection molding or by casting or by any different kind of production technology, if the part fulfills the specification which is given by the OEM. And so the first thing is you need an inline qualification inspection, and if it is passed, then you can send the parts to the customer. But if it is rejected by any kind of measurements, you need maybe to refurbish, or even you can just throw it away. And the problem is mostly the workers at the night shifts, they have not this knowledge, not this training on these very complicated machines to pass these kind of quality inspections. So mostly there's a jam in front of these laboratories or even these departments, and maybe 3 weeks later, the head of the measurement department came to the general manager and said, "Oh, 3 weeks ago, or even 3 months ago, we produce a lot of rubbish," and or even he has a phone call by the OEM, and so the guys there are not really amused because they got a whole bunch of parts which are not passing their quality requirements, and they have to be sent back, or even they have to put in a bin. Yeah? And this is what our thoughts and this leads us to our concept, what we like to do, and this is a nice story to have these kind of program by the Interreg to get money to build up a prototype and to test it. And so the basic idea is that we have a machine which is very easy to use, so we can load the component, and we have a measurement process which is taught in, and the machine should be absolutely easy to use, to operate, and it is for sure it's scanning by a structural light scanner which are introduced, and at least we investigate which kind of quality management program can be used. So we've found, for example, Polyworks, which is quite common, which is also, for my opinion, it's a leader of this kind of technology. And we have a nice connection to our company in the very south, which are the dealers here in Germany. And with these programs, you can evaluate the structure, the 3D data, and when it's passed, you just unload it out of the machine. And if it is not passed, the machine gives an alarm. For sure, this can be done 24 hours, 7 days a week. And someone who is responsible in the company is informed that he maybe rush into the production area, or even he gives some advices. For example, stop this production of this specific part, which is just not passed, because it is to expect that all the next parts have the same fault. For example, when you have a CNC machine and a drill or a thread is broken, for sure the next hole cannot be drilled, and so every following part is also wrong as the one which is inspected, and the alarm is come up by, okay, there's a hole missing. And yeah, this is what we did. This is a very huge machine. If you can go maybe through the specification, we have a turntable which is around 600 millimeter in size, and also the weight of parts can be up to 100 kilos. And the whole cabin is closed, so we have the possibility to use also laser scanner systems. We have a laser scanner system in our collection for testing, and this is a class 3 laser, which is not or can't be used in open surroundings. So the area of the scanning field is completely closed, and also for the structural light scanning system, it is very nice that the light, the ambient light is quite equal, and so after passing the parts into the system, the door are closing automatically, and then the investigation starts, and if the part is passed, then the door opens, and the workers take out the part. And so internally we have a mechanism like 5 axes, so we can go up and down, we can go forward and backward, sideward, so we reach any topic or even any area of the parts to be scanned. And in front of these tips, there's the scanning system with 2 cameras and a beamer system. And for unloading and loading, there's also the possibility to drive the whole turntable out of the machine. Everyone who knew, for example, in CNC milling machine, he knows the problem that the workers have to go more or less into the machine to fix it, to make manipulation on the parts which given into the machine. And so our idea is to drive out the whole turntable, for example, to feed it by a robot, or even you can go with a forklift over it, or even the crane system of the company can be drive there and load up the part onto the turntable. For example, you must always remember 100 kilos is not a weight which a worker lift by his own, or even it's not wise to do it by 2 or 3 people by hand. So you might use a forklift or something else to place it. The second thing is that we have a specific holding system, for example, as shown here as the photos. And the idea is to have a specific holding system for any part which have to be examined by the machine. And there's an RFID chip into these holders, where the identification to the machine is given by the program and by the RFID recognition. And after this, the machine can load the specific program. So, for example, what you have to show the workers is, for example, a blue, a green, or a yellow holder for these maybe 3 different parts, which is made in the night shift. And even the holders are designed in this way that the fixing of the part is absolutely is just working in one way. And so you can pass in these holders into the machine. And for example, here we have the part I shown before. For example, here what is needed is this initial sampling report, and all these you see these blue items which are marked by numbers 14, 15, 16 have to be examined, and so we scan these in this machine with a specific holder. On the right side you see the results in Polyworks, and also the reporting. There's a lot of different way you can report it, and you can see also 2 non-IO examples where we can filter out because we are only interested in the measurements which are not okay. And so there's a kind of string in the program which gather all these informations and send it over to a kind of website, and give maybe with an SMS or with an email an alarm to a specific person, which is given to the program, and then an alarm maybe in the night shifts come to these responsible people, and he can go and have a look at his computer and see such a report and see what kind of mind he make up to make a decision what's going on with the production. So this is my slide for this day and night report 24 hours, which can be sold by our program. So the prototype we did is I have a lot of photos wide open. For such a pity, we have an accident in the last days. So the electronic is broken by a wrong cable, so it's damaged. And what I like to present was a video, but it's not able to make a video now. This is the mechanical prototype, which is built up in Felbert, and here is also the scanning system installed to make such scan investigations by geometry. And yeah, I did some computer renderings where you can see the touch screen on the doors, the possibility to drive out the door with the turntable, and to load and unload the machine. And yeah, this is more or less the result of our program, and I thank you for audition.
Yes, thank you very much for introducing the project. I think possibly, okay, it was an applause. Okay, are there already questions? If so, you can activate your microphone, or you can raise your hand, or you can put it into the chat, so I will answer your, I will read out your questions loud. So I think with your holders and the RFID tags, I think your system is pretty fail-safe. This is a very nice concept. Yeah. Because, as you already said, it's not possible to put the wrong piece on the wrong holder. So, okay. So I think in the end, you have something like a digital twin. You have your reference, your 3D data as reference, and then you compare it to the parts you produced, or the customers produced. You said it's an inline system. How much time does a 3D scan take in the end?
It depends on how many shots have to be bent for the scanning. For example, one scan is less than a millisecond. And also it depends a bit on the surface structure. For example, very black or very shiny surfaces are much different. So we need in this time, we need maybe 1 or 2 or 3 shots in each position. So this can also extend the scanning time. And for example, when you look at the part, and you can imagine that a light is going straight on the part, on any area where is a shadow, there is no data. So you have to turn it and take another shot. And so for a specific part, for example, our example parts, we need around 40 shots. And also the way when the turntable turns to reach the next position. So it's less than maybe 25 up to 30 seconds, plus opening the doors and closing the door. That's it. Yeah.
Okay, so I think possibly it's a bit faster than it looked in your video where you scanned the AirPods. Okay.
Yeah. Yeah.
Okay. So, and Alex van Geldrop, you have a question.
Yeah. So thank you, Thomas. Very interesting presentation, and it looked really nice. So very.
Oh, thank you.
Very impressed. I had 2 questions. The first one was, I'm not sure if I understood it correctly, but in your example, you mentioned that you had the example that at some point you did a scan of something, and if it didn't work, if there was a product that wasn't up to the code, to the quality inspection, then you could see on the scan that it might be because, for example, a hole wasn't drilled or etc.
Yeah.
And that analysis of the difference between what it should be and what it is that something that is automated within the scanner, or is it something that you have to do by hand per case?
No. This is the specific job from this Polyworks program, or even can done by also other software, for example, geometric control.
Yeah.
And this has to be taught in by an expert. But the worker, or even the guy who's using the machine, did not need this knowledge. This is done before, and this is a complete or total automatic process. So, for example, if you can imagine a kind of local network, the scan part is just dropped into a folder as a specific file format. We call it STL, stereolithography format. This is a kind of triangulated point cloud. And for example, you have maybe 50 folders for 50 different items, different products. Yeah. And if the Polyworks scans these kind of folders, and if new parts reach the folder, for example, 1 or 10 or 1,000 parts, there's a kind of macro that the geometry is dragged into the program, and then automatically the whole process is started to analyze the geometry. And for example, in this example, we have about 26 measurement points, which is the OEM interested in. And this needs around 20 seconds to analyze it and to give the report. So what you can do in the background is for sure statistic. You can make the whole measurement reports with all specs, but in our machine, we are more or less interested in the data which is not given to stop the production. But also you can do, for example, what is told before, like this digital twin, or make normal scan operations. But our focus is really to establish a machine which is used for a night shift, where the specialists are not willing to fulfill their jobs. Yeah.
Great, thank you. Very clear. And then the follow-up question: you mentioned in the night shift as a very specific example. Is it also something that you're already working towards with a potential first customer or something, or is this something that has to happen? So, what are the next steps after this?
The next steps is different sizes. So we design a kind of mid-range scanner. So, for example, there are some scanners on the market where you can go into with the whole structure from a car or for much bigger parts. But these scanners are so costly that the KMU industry is not willing to give money for such kind of machines. This is more like automotive industry or aeroplane industry, which are able to buy such machines. And even we're looking maybe for smaller machines. For example, when you can imagine a part with 100 kilo is extremely huge, but maybe for people who produce smaller parts, we can reduce also the size of the machine. And also what we are looking for is to add a robotic system to place the parts into the machine and take them out. This is also one aim we are going for the next step. Yeah.
And the robotic system for increased accuracy, or because
No,
then you
loading, unloading, so that we can go for example, in line.
Yeah.
Yeah.
Interesting. Okay, thank you. Very clear, very nice.
Yeah.
Are there any further questions until now? Okay, but in the meanwhile, I have another question. You designed this beautiful box for your 3D scanning, and you also showed this tripod system. What will you develop both? Also the tripod system for bigger things like complete cars, or has to be some kind of box where your robot arm can go around the object with his scanner?
The tripod system is more or less an expert system. You need absolutely to know where you place your tripod, how you angle the scanner, how you move the scanner, how you use the software. And this is completely different from our system. We have an absolutely easy to access system, and for sure, the background of the systems are absolutely equal, but for example, we don't want, for example, the workers to manipulate into the machine. For example, when we open the door, the whole scanning systems drive beneath the doors, and so they are completely hidden. For example, someone wants to clean up the objective of the scanner, because he has a photo camera by himself and said, oh, maybe there is a fault by dirt on the camera system, and then he adjusts the whole system. This could be absolutely wrong treatment, and so we don't let the users to these specific areas of the machine, and this is totally different from the expert systems you see before. So there you can exchange, for example, the camera system. You can change the angle. This is completely fixed in our machine, and then the client needs a different, for example, accuracy. There's a service team which goes to the machine and change the accuracy, and that's it. Or even the program can be given to these companies as a service, or even they can train their own technicians to make this service by themselves. But what we learned, if we go in contact with some industry clients, they have no capability to do it by their own. They want to buy the machine, and then they want also to buy all the holders and even the programs behind. They are concentrating on their production, and they are not interested to set up a whole quality department just maybe for specific specifications, or even for special tasks, not for daily use.
Okay, so you also mentioned reverse engineering. So there's my question: what exactly is your business model? Do you want to sell the machine, or would you also sell the service? I'm thinking about you met injection molding at polymers, or possibly these the machines where the vinyl records were made with. I know that there are some old machines and they just repair the machines, but in this case, reverse engineering would be a nice way to keep the industry running. But that means that you need your scanner just one time. So maybe is there also a thought about just selling the service? If you say, I built such a big machine where you can put in complete cars, but I have it in my hall and you can use it, you can rent it. Is this also an opportunity for you, or would you rather say either you can sell it or you?
Not really. We really focus on producing the machine, and we are sure that we also have to give the customer some services, for example, to set up the machine, to train the technicians, or even to sell the specific holding systems, and even giving them the specific programs to run the machine. This is for sure the business case we are looking for.
Okay.
And, for sure, you can do also 3D scanning and reverse engineering, but this is a service we actually give to the industry, and this is more or less also make very individually with a handheld system on the spot, and you don't need such a heavy machine.
Yeah, that's true.
Size,
Yes, in this case, you can use the professional machines because you are using them. Okay, so you already have this services. So this is good to know.
This is actually the idea is born especially by these kind of services we always given to the customers.
Okay. So great, thank you. Now, are there further questions? I think not now. So maybe later. So what? Yes, that's the point. So we are planning to publish the screen recording later on. So I will send you the link as soon as it is released by Thomas Kropp. And I think then possibly we can also put the contact data into the email and send it to all participants so that they have the opportunity to get into contact with you afterwards if there are any questions or if they have someone else who would be interested. So again, thank you very much for your interesting talk and the introduction into AutoMess3D. And I think this was in the first season, it was the second one. I think now it will take a little time until the next innovation projects will finish, and then we can present them. So you have to wait for the next webinar. So from my side, thank you very much for your attention. And I don't know, Alex, if you want to have some last words.
Well, thank you, Hendrik, for your work in this and for the presentation and for hosting. And Thomas as well, of course, for his time and energy.
Yeah, thank you.
Okay, so thank you very much and have a very nice evening and see you soon. Bye-bye.
Bye-bye.
Bye-bye.